Hello everyone, welcome to the second video in the tutorial in the new remastered tutorial top-down zombie shooter series. And yeah, so today we're going to be creating a game manager class, and that will basically manage the game loop or the while loop, which basically is going to manage the refreshing of the game and the updating of the game and the rendering of the game. So let's get started. And yeah, so this is where we left off previously, and yeah, so we're gonna create a new class inside the main package, and I'm gonna call it Game Manager. So I'm just gonna name it as Game Manager, and yep, we're done. Now the game manager is going to have a few important information, like if we need to have a frame rate, a maximum FPS and stuff like that. So yeah, but for now we're just going to create a game manager constructor. We need to have two important methods, and they have to be public. They don't have to. Public void update method. This is the update method. So all your updating code goes inside here. And the render method. So this is where all the rendering or the drawing code goes inside here. And since it's a game manager, we're going to be working on an endless loop. We want to extend the thread. Extend thread and have it work from a thread. I'm gonna call it game manager, or I'm gonna rename the class to game thread. No, just game manager, yeah. So public void render, and yeah, so since we're inheriting the thread class, we're going to inherit a method. We're extending from the thread class, so we're going to inherit a method called the run method. Public void run. And yeah, as you can see, there's an override thing. You do not have to put this. It's just there, just in case. But it's there. We do not need to put that in. So this is the class already, and yeah, so let's just test if it works. I'm gonna have a few things just gonna display updating inside the updating dial inside the updating function, and inside the rendering function we're just gonna say rendering. We're just gonna display rendering. And we're just gonna create, I don't know, a function, call it tick, I don't know. No, we're just gonna put it inside here and just call update and render once. And let's run, and as you can see, okay, something. Oh, we didn't even call the thing in the main class. So we need to create a game manager object inside the main class, so that we can link to it. So yeah, let's go and create a game manager object. So down below, we're just going to say game manager equals to new game manager, and we're just going to call the manage.start method .start. If you're probably wondering why is the start method, it is not inside the manager class. Remember, we're extending from thread. So if you go and control click on the start method, it's going to take us to the thread class, and it's going to show us the start function. And yes, so if we save and run, updating and rendering comes up. Now remember, this happens once. We need to have it happening continuously so that it can continuously update and render our game and clear and refresh and do all this other stuff, cool, nice stuff. So for that, we're gonna have a new boolean value. We're gonna call it running. So while the game is running, we should just continue. And yeah, so I'm just gonna leave it to public. I'm gonna just set it to public. It's your preference if you want to make it private or public. I just prefer with public because I'm the only one who's making the game anyways. So yeah, so and inside the while loop, we're going to have a while loop, which is only going to run if it's running. Whenever running is true, the while loop will continue running. If running is not true, then we're not gonna run. Running equals to true. So yeah, and if we do this, it's gonna come up, it's not gonna end, updating, rendering, updating, rendering, all the way. So that's a success. So now the other problem is if we close this window, it's gonna continue. Oh, it didn't. That's great. So yeah, so it didn't continue. Anyway, so yeah, so that's actually a cool thing. I thought it wouldn't continue. Anyway, so yeah. So now, if we, for example, if I wanted to count the amount of times we're updating or rendering, we're going to see that. In fact, let's just do that. Let's count how many times we're updating. So yeah. So we're gonna use a few different classes and different tools. So we're gonna use system.nanotime to get nanoseconds and all that stuff to use it for counting. And yeah. So instead of the run method, we're gonna create a new, an integer variable, and we're gonna call it the counter. Int counter. Now I'm just gonna call it int counter equals to 0. And then at the end of the while loop, we're gonna no, not here. We're just gonna create an if statement, and we're just gonna hold on. So basically, after every second, we want to count how many times we have called the update function. So inside here, we're just going to say counter plus plus, counter plus plus, counter plus plus. It's short form for counter equals to counter whatever counter's value was plus 1. So it's just adding 1 to counter every single time we run. And inside here, we're just going to reset counter equals to 0. Equals to 0. We're going to reset, as well as display the value. And we're gonna also display that with some text, and I'm just gonna say dash frames this second. So, or updates, I don't know, it doesn't really matter. So I'm just gonna call it updates. So now we need to do the hard math. So basically we want to count time, and to count time we're just gonna need current time, the previous time, and a few other times. So yeah. So and to do this we're just gonna say I don't know how to go about this. So first things we need to know is that there's a billion nanoseconds inside a second. So yeah, so now let's get started. So now we're gonna need a few time values, long now and past. I'm gonna say past equals to system.nanotime. You're probably wondering why am I using long. The reason for using long is that what is it called? The data type that we're using for that is being used as for time is a much longer value than an integer, so it's just going to be a long. It's a long integer basically. It's too long. It's too big. It's too big of a number to be stored as an integer. So yeah, let's get started with counting. So the past time or past. Yeah, I think it should be past. Just gonna refactor, rename. Last time. I'm just gonna put last time. So that's last time. No, not last time. Refactor this and then rename it to last time. When you refactor, rename, it changes the names across every single variable. Yeah. So last time. So last time it was nano system nano time. So we just need to get the now time, and then we're just gonna say now equals to system dot nano time. And then inside here we're just going to say last equals to now last time. And yes, so basically what we're doing now is just going to say now, if now minus last time, now minus last time is bigger or equal to 1 billion nanoseconds. It's 1, 2, 3, 1, 2, 3, and 1, 2, 3. That's a billion. And yeah, so we're just gonna encase this in curly in parentheses. And here we go. It's going to display this message signifying the seconds. And yeah, so now let's try this. Okay, something isn't working, right? So first of all, let me just not update and render. So as you can see, we can see it properly now. So it's gonna show after every second, as you can see, 1, then 2, then 3, then 4, then 5, then 6. So as you can see, our computer can run around how many times? 73 million times per second. So I don't know if that's fast or slow, but yeah, this value, this number over here, isn't going to be the same on other computers. So it means the game we make will run on different speed on different PCs. And if we wanted to add multiplayer to a game, it will not be fair. It won't be a fair gameplay. So yeah, so in the next video we're going to be setting up an FPS timer. So yeah, and guys, peace. Please, the source code will be linked down below in the description. Please subscribe and like my video. Peace.